This is the fire raising experiment. Now straight away we're using fire, so obviously this has to be done in a safe way. I want this done with grown-ups around, watching what's going on, whatever way else you choose to do it. You don't need much stuff for this, which is nice. You need a tray, a baking tray. You can see here I'm using a glass tray, but a metal tray is fine. I'm just using a glass one because it's probably a bit easier to see right now. You need to put in about 2 centimetres of water. So I've already got the water in there, about 2 centimetres deep, okay? Then you need a small tea light candle. Make sure it floats. Most of them do, but now and again with the metal around it, it can make it too heavy. This is fine, this does float. So make sure it can float, okay? You also need a glass. Now, I'm using a pint glass, and as you can see, I've got these little blobs of blue tack on here. You can use plasticine actually, but I like using blue tack. It tends to grip better on the glass. Plasticine isn't as sticky, that's why we use blue tack to stick things. So of course I've got my blob here, and I took it from there, and I've got 4 little blobs, and if you look carefully, they're all about the same size, not exactly of course. Now I want you to notice the way I've put these little blobs here. All of them are sticking up quite a lot above the rim of the glass. You can see that they're all sticking up quite a way. Now the reason for that is because I'm going to be turning this glass upside down, and hopefully you're going to be doing the same with yours, and very carefully lowering it over the candle. And when it rests on the bottom of the tray, I want there to be a gap. And that's why, if you can see on my hand there, I've got a gap. So at the moment the air can come underneath and it can get under the glass. But of course this will be in the water, so I want the water to be able to do that, okay? Easy to do, but I just wanted to make it clear you do need a gap there. So this is what I want you to do. And remember, grown-ups around for this one. You need to float the candle gently on the water. Then you need something to light the candle with. I'm using a match, as you can see here. Okay. And the last bit is, let's bring it over here a bit. Remember the flame there, we don't want to get burnt by it of course. Oops, floating around. And then you just lower the glass over the flame until the glass rests on the bottom of the water. And watch really carefully what happens to the level of the water inside the glass. Off you go. This is what should happen. Lower it slowly, with the candle in the middle. Watch the surface of the water inside. So, what's going on? How can the fire cause the water to rise up in the glass as you saw it? Let me just point out a few things I hope you noticed in this particular experiment. Hopefully you noticed that when you lowered the glass, the level of the water inside the glass went down just a bit below the level of the water outside. That's the first thing I hope you noticed. Then you probably noticed, if you're watching carefully, even while the candle was still burning, the water started coming up very slowly inside the glass, very, very slowly, while the candle was burning. Then I'm hoping you noticed that the candle started what we might call guttering, started flickering as it was actually beginning to go out. And when it actually went out, the water did go up quite quickly then. So, why is that? Well, when we lowered the glass over the water, and over the candle, what was happening was the heat from the candle was coming pretty well straight up into the glass and heating up the air that was trapped under the glass. Now when air gets heated, like many materials, it expands. But think about it, if it's expanding, it's going to use up all the space. So what was happening was, if you can imagine it, as I was lowering the glass, the air was getting heated up and expanding, and some of it was being pushed out because it was getting taking up too much space inside the glass, so it was coming out and flowing out. We couldn't see it because it's invisible. When I lowered it down over the candle into the water, it was getting pretty hot by now. I popped the glass right down and rested it on the bottom of the container here. The candle carried on burning for a little while, You'll notice, remember, that the air that was trapped in here was pushing down on the water too, and that's why the water level went down a little bit at first. The candle carried on burning, of course, and was using up oxygen. Now the oxygen that was in there, of course, is taking up some space in the glass itself. So as the candle was using up the oxygen, some of that space was taken away because the oxygen didn't need it anymore, it wasn't there. So the water rose up a tiny bit to replace that space. But most of the motion happened, you saw the water rise up fairly quickly after the candle had actually gone out, almost immediately actually. And that's because when the candle stopped burning, it stopped giving heat to the air in the glass, the air started cooling down, and when things cool down, especially air, it takes up less space. So remember, when we said it was heating up, it took up more space. When it cools down, it takes up less space. So in other words, it was shrinking. So when the air inside there was getting cooler, it was shrinking pretty quickly, and it was shrinking and shrinking, and it created a suction effect, which was actually caused by the air around us in this room right now, pushing down on the surface of the water, and pushing down on the surface here, and causing the water actually to be pushed under the glass and come up and take up the space as the air contracted and took up less space. And that is why the water went up in the glass. One other thing I'd like to mention to you, in some books you're going to read that the reason the water goes up is because all the oxygen is used up, and you see the difference, how much oxygen was used up by how much water has risen up. That's not true, okay? Most of the motion happening here that you can see, most of the motion in the water was because the air trapped inside was cooling down and shrinking and taking up less space. That's why the water rose up, to fill the space that was being used up by the air when it was actually taking up more room. Other variables you can try. How about changing the speed that you lower the glass? Now think about it, if I go more slowly as I lowered the glass, I went pretty slowly before, but if I go more slowly, that will probably heat the air up even more before I get to finally lowering it over. What about if you go faster, lower the glass quite quickly? Think about it, that's going to mean it won't get so hot. The question is, will it make a difference that you can see? What about different size candles? That'd be interesting. I wonder if we can get maybe a bigger candle with a bigger flame, which would be hotter, of course. What about maybe 2 or 3 tea light candles, as long as you can fit them inside, of course. 2 or 3 tea light candles, will that make a difference? Of course, 2 or 3 flames are going to be a lot hotter than just one, so will that make a difference? What about the size of the glass? I've used a pint glass here. What if we use a much bigger glass or a smaller glass, as long as you can fit it over the candle, of course? And I'm sure you can think of maybe 1 or 2 other things.